Look at its integral. We have over here, we have in denominator, we have x, here angle is xx, here we have 2x and 3x. Okay, let's break these two into x. This is equals to sine 2x is what? 2 sine x into cos x, and cos of 3x is what? 4 cos cube x minus 3 cos x upon sine square x into cos cube x dx. Okay, now here one sine gets cancelled. From here also I can take cos common. Okay, I can take cos common, and then this will become what? Cos square. Therefore this is equals to, I can send 2 outside. Therefore we have sine and one sine get cancelled. Here this is what? Sine square. So I will have cos square x. Here 4 cos into cos is cos square, 4 cos square x minus 3 upon cos of cube x dx. And we have another also, I will write sine over here. Okay, one sine is over here, cos cube is there. Okay, now here also I can cancel, this is same as 2 integral, here will be only one cos. Okay, here 4 cos square x minus 3 upon cos x into sin x dx. Okay, now let's do one thing. Let's this upon this and this upon this. Okay, let's separate the numerator. Okay, here what I have 2 integral. So if I separate, then what will come? 4 into what? 4 into 1. We have cos of x upon here. Okay, one cos gets cancelled. Okay, sine of x, I'll write here dx, and bracket minus 3 is there, 3 is outside. What we have? 1 by cos x into sin x dx. Now integration is this what? So integration of this is 2 bracket, differentiation of sine is become cos, therefore that is log of denominator. Okay, that is log of sine of x minus 3. Look at here. Okay, see here sine 2x is what? 2 sine x cos x. Okay, it is of the form this. So let's adjust 2. Okay, and then I need 2. Okay, so I have to multiply over here into 2. Okay, so into 2 here. Okay, so these 2 gets cancelled. Therefore here 3 into 2 is what? 3 into 2 is 6. 1 upon 2 sin x cos x is what? Sin 2x. Sin 2x is 1 by sine is what? Cosec. Okay, so integral of cosec of 2x dx. Okay, this therefore is equals to 2 here 4 log of sin x minus 6. Okay, integration of cosec is what? Log of cosec 2x plus cot of 2x upon divide dx of 2x is what? 2 plus c. So you can cancel with this 2 3s are, or you can send all terms over here, or you can keep this like this. Okay. Welcome to my channel. Look at this integral. We have algebraic function over here. Now and then this raised to pi, we have pi over here. Okay. Now what we can do is we can do by rationalize, but it will be very much lengthy over here. Now what I will do is I will use by substitutions, hyperbolic substitutions. I will use x equals to sine square hyperbolic substitution. Why? Because we know that cos square hyperbolic x minus sine of hyperbolic square x equals to 1. Okay. Now if I substitute x equals to okay, sine Okay, if I substitute sine of hyperbolic square t, okay, if I substitute x equals to hyperbolic square t, then from here what we'll get, is, from here what is sine hyperbolic t, okay, from here cos of hyperbolic square x equals to 1 plus sine of hyperbolic square x. Now if I want to remove square, then I can have to take square root on both sides, this, okay. Therefore 1 plus 1 x plus 1 or 1 plus x is what, this will be cos hyperbolic square, okay. Or you can say, we can keep like this, okay. For time being, let's do like this. From here what is t, okay. Now squaring on both sides, what I get, x square equals to, taking square root on both sides, if I want to remove this, square root of x equals to what, sine of hyperbolic t. Therefore, okay, therefore t equals to sine of hyperbolic inverse root of x, okay. From this t equals to this, okay. Now from here what is dx, okay, differentiation of dx equals to what, is 2 sine of hyperbolic t, and then differentiation of sine is what, cos of hyperbolic t, okay, into dt we have, okay. Now we have dx in terms of dt, okay, in terms of t dt. Let's substitute over here, okay. Therefore this is same as integral x plus 1, okay. X plus 1 is what, square root of, what is x, x is what, sine of hyperbolic square t plus 1 minus square root of sine of hyperbolic square t into, now what is dx, 2 sine of hyperbolic t cos hyperbolic t into dt, okay. Dx is in terms of this, okay, is equals to sine hyperbolic square plus 1 is what, cos hyperbolic square, okay. Now cos hyperbolic square and square root get cancelled, we have cos of hyperbolic t minus sine hyperbolic square and square root gets cancelled, we have sine of hyperbolic t into, okay, these two we have sine of hyperbolic t into cos of hyperbolic t into dt, okay. Remember what is sine hyperbolic t and cos hyperbolic t in terms of e, okay. We have this formula, we have sine of hyperbolic t cos of hyperbolic t in terms of this is what, e raised to minus this, since it is t, so t plus e raised to minus t, here plus t upon 2 is equals to e raised to t minus e raised to minus t upon 2. Let's use this over here, okay. Let's use everything over here and let's see what are the terms which we can get cancelled. This equals to integral, what is cos, okay. Cos we have e raised to t plus e raised to minus t upon 2 minus e raised to t minus e raised to minus t upon 2 into twice sine is what, e raised to t minus e raised to minus t upon 2 into e raised to t into e raised to minus t upon 2 dt, okay. Here I will do some shortcut over here, this into this. Now if I take LCM, okay, if I take LCM over here, what I will get, I am taking LCM over here, then these two will be hold down, okay, or you can say, so let's write one step, e raised to t plus e raised to minus t minus, okay, here e raised to t minus minus plus e raised to minus t upon 2, okay. Now is there some term which you get cancelled? Yes, this term gets cancelled into what we have 2. You can say these two and these two gets cancelled. These two and these two gets cancelled. We have these two is over here. These two is over here. Now it is only a minus b into a plus b. Okay. what we have? A minus b into a plus b is what? A square minus b square. Okay. Therefore, this is e raised to t the whole square means what? E raised to twice t minus e raised to minus twice t dt. Okay, now we forgot over here pi is there. Okay, here we have pi, here we have pi, we have pi, here also we have pi. Okay, now this is equals to integral. Now e raised to minus t, e raised to minus t is twice e raised to minus t upon 2 raised to pi, okay, and 2, this is integral into 2 e raised to 2t minus e raised to minus 2t dt. Okay, now here we have 2 gets cancelled, we can send this pi inside e, therefore this is equals to, so if I send pi inside over here, what I'll get is e raised to minus pi t, and this 2 I am sending out, this is 2 into, okay, now this into this is what? Into e raised to 2t minus e raised to minus pi t into e raised to minus 2t. Okay, now if base are same, you can add the indices. Here we have 2 integral of, if I take t common, here I will get 2 minus pi t minus e raised to, here if I take minus common, here 2 pi t. Let's see, minus here will be plus over here. Okay, here minus all minus. Now this is what? Integral with respect to t. Now let's integrate this with respect to t is same as 2 e raised to 2 minus pi t upon differentiation of this with respect to t means what? 2 minus pi minus. Okay, here 2 is outside, we have is e raised to minus 2 plus pi t, differentiation of this is what we will get? Minus plus 2 plus pi plus c. What is t? T substitute this. Okay, e raised to 2 minus pi t means what? Sine hyperbolic inverse root x upon 2 minus pi plus e raised to minus 2 plus pi sine hyperbolic inverse root x upon 2 plus pi plus some constant c. Okay, this is a recurrent, so you can keep, or you can take this common. You can take this common, or you can keep like this. Now this integration was asked by MI3 integration B qualifying exam. So this is just qualifying exam, please keep in mind. So as you know, MIT integration B has different levels. Now look at this integral. We have 0 to pi by 2 x into pi cos of this into dx. Now here this pi is what? This pi is product of this. Okay, this capital pi is the product of cos of x upon 2 raised to k, where k goes from 1 to infinity, and this small pi is, we have its value. So this pi and this pi are different. Okay, now in order to solve this, let's see, let's target this first. What is this first? Let's expand this. So let's consider this part. Let's consider pi of cos of x upon 2 raised to k, where k goes from 1 to infinity. Now let's substitute over here. So I am considering only these parts. Okay, so this equals to, when k equals to 1, what we have? Cos of x upon 2 raised to 1 into, when k equals to 1, when k equals to 2, what do we have? Cos of x upon 2 raised to 2 and into cos of x upon 2 raised to cube and so on, what, up to infinity. Okay. Now remember we have this formula. Remember, what is sine of 2x? Sine 2x is what? 2 sine of x into cos of x, right? So from here, if I want to find cos x, what is cos x? Cos of x equals to what? Sine of 2x upon 2 sine of x. So if I use effectively this, here cos of x is over here, in each term over here, let's see what it comes. So this is equals to what? Instead of x, I have to substitute over here x upon 2 raised to 1. So this is same as sine of what? 2 into x upon 2 raised to 1 upon 2 sine of, what is x? Or x is what? X upon 2 raised to 1. What I am doing, just I am applying this formula over here, okay, for each and every term, into here I will get what? Sine of 2 into x is this, x upon 2 square upon what? 2 into sine of x upon 2 square into sine of 2 into here x is x upon 2 cube upon 2 sine of x upon 2 cube and then goes up to infinity. Let's keep aside this all 2 here, okay. Here let's keep aside all 2 here. Now these 2 and these 2 gets cancelled. So I write one step over here. So this is same as sine of x upon 2 sine of x by 2. Here if I, these 2 and these 2 gets cancelled, if I have sine of x upon 2 sine of x upon 2 square into here sine of 1x, 1 2 gets cancelled, x upon 2 square upon 2 sine of x upon 2 cube and so on up to infinity. This term and this term gets cancelled like this, and this term and this term gets cancelled. Similarly, all the terms will get cancelled, but these 2 will be remaining. Now if I want to write last term, what I will get? I will get is what? Sine of 2 into upon 2 raised to infinity upon 2 into sine of x upon 2 raised to infinity. Okay. So, but this term and that term will get cancelled, but the remaining term will be this term and this term, right? So this is equals to what? Sine of x upon 2 raised to 2 up to what? 2 raised to infinity into sine of x upon 2 raised to infinity. Sine of x upon 2 raised to infinity becomes 0. Okay, sine 0 is 0. Therefore, sine of x upon 0, it becomes what? Infinity. Okay. So, let's not consider about these terms up to infinity. Let's consider up to some finite terms. Okay. So, instead of this, what I can do is, I can write some finite terms. Sine of 2 into x raised to x upon 2 raised to k upon 2 sine of x upon 2 raised to k. Okay. Where k is what? K is finite number. Okay, finite number. Therefore, here what will get is, here we will get k over here. Here we will get k over here. Okay. So here we will get k over here. Here we will get k over here. Okay. So this will go. So this k should tends to infinity. Okay. Therefore, limit of k tends to infinity, sine of x upon 2 raised to k into sine of x upon 2 raised to k. So we need to solve this. So this is what, this is just this part, right? Is equals to limit of k tends to infinity. Now this, when this limit is k tends to infinity, therefore sin x become what? Constant. So I can send outside sin of x outside here, limit of k tends to infinity. Here 1 upon 2 raised to k sin of x upon 2 raised to k. Now here, if I want to use what? L'Hospital rule. What is L'Hospital rule? The limit should be what? Plus minus infinity, or if it is either plus minus infinity upon plus minus infinity, or if it is 0 by 0, then we can use this rule. Okay. But here this is 1 by infinity. Okay. So instead of this, what I can do is I can bring this up. Here sin of x, limit of k tends to infinity. So I can bring up this same as 2 raised to minus k upon sin of x. I can write like this also, 2 raised to minus k, right? So now it is already from infinity to infinity. So now I can apply L'Hospital rule. Okay. L'Hospital rule means what? We have to differentiate. If it is f of x upon g of x, then we need to differentiate what? Numerator differently as well as denominator differently. Here you cannot use u by v rule, or you can say quotient rule over here. Okay. For L'Hospital rule, you have to differentiate whatever denominator you have denominator, what you have numerator, you have numerator in a straight way. So now let's differentiate this with respect to what? K. So this is same as, I will write over here, sin of x. I am differentiating this with respect to k. So I will get minus k into 2 raised to minus k minus 1 upon what? Here differentiation of sin is what? Cos. Cos of x into 2 raised to minus k. Again I need to differentiate this with respect to what? With respect to k. Okay. So if I differentiate this with respect to k, now x become a constant, x. Again differentiate this with respect to what? With respect to k. So I'll get minus k into 2 raised to minus k minus 1. Okay. Now this term and this term gets cancelled. Here I forgot to write over here. Here we have limit of k tends to infinity. So here we have sin of x. Now these two gets cancelled. What we have is when k tends to infinity, this becomes 0. Okay. Cos 0 is what? Cos 0 is 1. So with this become 1, and what we have is we have only x. Okay. So we have only 1 by x. So we have sin of x upon x. Therefore this part, whole this part become what? Whole this part become sin x upon x. Integral 0 to pi by 4. What we have? X into sin of x upon x dx. So x gets cancelled. So we have the integration of sin x is what? Minus cos of x, limit is from 0 to pi by 4. So upper limit minus lower limit minus cos of pi by 4 minus cos of 0 is minus cos pi by 4 is cos 45 is 1 by root 2, cos 0 is minus 1. So if I send this here 1 minus 1 by root 2. Okay, this is the required answer for this. E raised to log, e and log gets cancelled. Therefore this is into dx. This is same as this 1 by log x I can bring down over here. Okay, therefore this is same as e raised to I will bring this 1 upon log x into what we have is we have now log of x dx. This gets cancelled. What we have is e, integral e raised to 1 dx. Therefore, it is same as e is outside, so e raised to x plus c. Given integration, it's better to put 1 plus e raised to x equals to u. Let's solve by u substitution. This is MIT Integration B 2020, question number 4. Let's substitute u equals to 1 plus e raised to x and du equals to e raised to x into dx. Okay. Therefore, this integration e raised to x into dx is my du. So, all numerator become du upon 1 plus e raised to x is what? U. U into log of u. Again here, now differentiation of log u is what? 1 by u. Again we can differentiate. Again we can substitute. Okay. Let's substitute v equals to log of u. Why? Because dv, my dv will be 1 upon u into du, means 1 upon du upon log 1 upon du. Okay. Therefore, du upon u I will get as a dv. Therefore, substituting this here, will get this become what? This become my dv, and what is log u is what? My v upon v integral. Now, integral 1 by v respect to v is what? That is log of v plus c, and what is v? V is what? Log u. Here log of u plus c, log of what is u? U is what? 1 plus e raised to x. Log of 1 plus e raised to x plus c. This is the required answer. Now let's combine, let's do one thing. Since minus x is there, let's rearrange this in this way. 1 plus x square plus x4, these are plus group, and if I take minus, then what will come? I will have x minus, okay, here plus x cube. These are all x even power, and this is odd power. I can write like this. Similarly, let's do this way. Here also let's combine this term. Here 1 plus x square plus x4 plus x raised to 1 plus x cube. This into, okay, is equals to integral. Now it is only from here something a plus b into a minus b. This a here, this term and this term are same, and this function and this function are same. Now we have a minus b into a plus b is a square minus b square. Here integral what we have, this square 1 plus x square plus x4 raised to square. We have a minus b into a plus b is a square minus b square. A square minus b square means what? X plus x cube raised to square dx. We have a plus b plus c the whole square is a square means 1 plus b square means x square raised to square means x4 plus c square means x4 the whole square means 4 to the 8 plus twice ab means x square plus twice bc means x raised to 4 plus 2 is what? 6 plus twice ac x raised to 4. This is a plus b plus c the whole square, and then minus, let's take bracket a plus b the whole square, a square plus twice ab means what? Twice 3 plus 1 is 4, x raised to 4 plus x3 the whole square is what? X6. Is there any term which we can get cancel? Yes, these 2x4 get cancelled, and x6 nothing is cancelling over here. Okay. Now is equals to integral 1 plus what is x4? Okay, x4 is what we have. X4 is these two gets cancelled. We have only one x4 plus x8 is how many? We have only x8. X square is how much? X square. And here we have 2x6. Here minus x6. I will get x6 over here. Let's integrate this. This is integration of x is what? 1 is x plus x4 is x5 by 5 plus x9 by 9 plus x cube by cube plus x7 by 7 plus c. This is the requirement. Today I will be solving MIT Integration B qualifying exam for the year 2023. Please keep in mind, this is just starting qualifier exam. They have semi-final, final, qualifier. Integration is from limit 0 to 4, here x, c, dx. Now what is these notations? Let's see. This we used to write x, c, 5. This is same as x factorial upon x minus 5 factorial into 5 factorial. Why? This is we have NCR equals to what? N factorial upon n minus r factorial into r factorial. We have this formula. From this formula, we are getting this. So instead of this, we can write like this. Let's see. This is same as this integral is same as limit 0 to 4. So here x factorial upon here x minus 5 factorial into 5 factorial into dx. Now remember the factorial notations. N factorial is same as what? N into n minus 1 factorial. This is same as n into n minus 1 into n minus 2 factorial. We can decrease till you have the last number, okay? Similarly, this x factorial I can decrease up to x minus 5 so that x minus 5 factorial and x minus 5 factorial gets cancelled. Therefore, this is same as integral 0 to 4. So, I can reduce this x factorial till x minus 5. So, x into x minus 1 into x minus 2 into x minus 3 into x minus 4 then x minus 5 upon x minus 5 factorial into 5 factorial dx we have. So this x minus 5 factorial and this x minus 5 factorial gets cancelled, and this 5 factorial I can send outside since it is constant. Therefore, this 1 by 5 factorial integral 0 to 4. So I can write like this, dx into x minus 1, x minus 2, x minus 3, x minus 4 dx. Now here you can integrate after multiplying all these. You have one options. Otherwise, you can do one thing. It will be somehow lengthy. You will get what? X 1, 2, 3, 4, 5. You will get x raised to 5 indices, and then you can integrate linearly. You can make these linearly and you can integrate. Otherwise, I will substitute this x minus 2 as a u. So let's see how it works. Now if I substitute u equals to what? X minus 2, then what? My du equals to my du is same as dx, okay? Therefore, from here, what is x? X is what? U plus 2. So instead of x, I can write u plus 2. What about limits? Limits we need to change. When x tends to 0, okay? When x tends to 0, u tends to what? Minus 2. U tends to minus 2. Because when x equals to 0, therefore, u become a minus 2. When x tends to 4, u tends to what? When x tends to 4, 4 minus 2 is what? 2. So therefore this is 1 by 5 factorial. Limit become what? Minus 2 to 2. X become what? X is u plus 2. Here u plus 2. Then x minus what? In terms of u is what? Here I will get u plus 1. And then here this is u. And then here u minus 1. Then u minus 2. And what is dx? Dx become my du. Okay. Now look at here. Now here we have u plus 1 and u minus 1. It is also from a minus b into a plus b. Here is what? A minus b into a plus b is what? A minus b into a plus b is a square minus b square is equals to 1 by 5 factorial. Integral is from minus 2 to 2. Now this become what? This become u square minus 1 square. So we have u square minus 1 square. 1 square is same as 1. Now if I combine these two, this become what? U square minus 2 square. Here u square minus 2 square is same as 4. So I can write 4 into what we have u and du. Okay. Now up to here is everything is fine, I think. Now remember one formula over here. We have integral minus a to a f of x dx, okay, is equals to 0 when if f of x is what? Odd function. Okay. When f of x is odd function, then integral of minus a to a f of dx becomes 0. Okay. What is odd function? Odd function is what? If f of minus x equals to minus f of x, then this is called what? Odd function. Okay. Look at here. Okay. Now here you can, here this is what? This is my even function. Okay. Here u square is even function. Here also u square is what? Even function. Here we have odd function. Even into odd is what? All this become odd function. Okay. Therefore the integral from minus 2 to 2 odd function become whole this become what? Become 0. Okay. So otherwise you can, one thing you can expand this and then after substituting this integral you will get the answer 0. Okay. Or you can, by using this property, whole this integration become what? 0. Now this integral is very easy. Sometimes MIT as well as JEE exam also they ask very easy questions. So let's solve very quickly within few seconds. Now from here I can take x common. This is integral. If I take x common here, what I have is 1 plus cos x. From here, from these two, if I take plus, okay, from these two, if I take sin x common, then 1 plus cos x dx. Okay. Now here 1 plus cos x is common. I can take once again. Here if I take 1 plus cos x common, here I will have x plus sin x dx. Okay. Then you substitute this, substitute u equals to x plus sine of x, then du equals to 1 plus differentiation sign is what? Cos x dx. Okay. Now whole this become your du. Okay. Therefore this integral become what? U into du, that is u square upon 2 plus c. What is u? X plus sine of x square upon 2 plus c. This is the required answer. Now this integration is lengthy but it's quite easy. Now think over here. Okay, in this we have all 1 2 3 4 5 all 6 trigonometric functions are over here. Now we don't have exact integration of sine square. Okay, in this what we have is we have exact integration is what? We have exact integration is sec square and cot square, because Integration of sec square is what? We have tan x. And integration of cot square is what? We have cosec minus cosec x. So let's try to bring everything merged into either cot square x or sec square x. Let's see. Now is equals to sin square x plus cos square x is what? Is 1. Now this what? This is 1. We know 1 plus tan square is what? And 1 plus tan square become sec square. So from here to here become what? Sec square x plus, I will write here, and here we have cot square x plus sec square x plus, what is cosec square? We have 1 plus cot square x is what? Cosec square x. So instead of cosec square, I can write 1 plus cot square x is 1 plus cot square x. Now this is here, this is dx, sec square is 1 plus here, this is 1 plus tan square become a sec square, and then cot square over here, and then sec square is here. Now sec square plus sec square is what? Twice sec square. This plus this is twice sec square x plus. Now this cot square and cot square, if I add, now 2 cot square x plus what is remaining over here is only 1, okay, 1 dx. Now integrate of this, 2 is constant, 2 outside, integration of sec square is what? We have tan x plus, here minus will come, minus 2 here, integration of cot square x is cosec x, integration of 1 is what? Plus x plus some constant. From here you can take 2 common, 2 tan x minus cosec x plus c. Okay. Welcome back to my channel. Now we need to integrate this. Now let's do one thing. Let's send this inside. This is same as, let's send this and this. This is equals to integral 2 into e raised to log x raised to square into log x plus e raised to log x raised to square into dx. Now look at here, okay. Now if I substitute u equals to this, let's see this its differentiation, whether it's coming or not. Why? Because we have integral, we have one formula of integral of e raised to x. Since it is of the form e raised to x, we have e raised to x into f of x plus f dash x. Now if you are getting e raised to x into some function of x and plus that derivative, you are getting that, then this integration is equals to e raised to x f of x. Let's see whether this is applicable over here or not. Let's check this differentiation first. So let's say u equals to e raised to log of x raised to square. Therefore du equals to du by dx, or du equals to e raised to x is what? E raised to x is as it is, e raised to log of x raised to square into d by dx of this is what? 2 log of x into d by dx of log x is what? 1 by x dx. Now we have this, okay, we have log of x, 2 we have, but 1 by x we are not getting. But if you adjust 1 by x over here, that will be difficult, okay. Now let's do one thing, this integral, let's integrate this first, okay. Let's integrate this first. So I'll write one step over here. This is same as integral 2 e raised to log x whole square into log of x dx plus, or you can say this, I'll use second bracket, plus integral of e raised to log of x raised to square into dx. Now let's integrate this. Let's see what comes. Okay. Now in order to, let's keep this for time being and let's integrate this. Now this is, we can consider 1 is there. Okay, 1 into anything is 1. So let's apply by DI methods, or you can say tabular methods, by integrating this. So now by DI methods, we'll keep D here, we'll keep I here. Now integration of 1 dx, there will be easy one. So I will keep over here, I will write over here 1, okay, this 1 over here, and this term means e raised to log of x raised to square. Now this column is what? Differentiation column. This is what? Integration column. In integration column, I am choosing 1 over here. Differentiation column, here I am choosing this. Okay, differentiation of this is this we have. Okay, differentiation of this is what we have. We have is e raised to log of x raised to square into 2 log of x into 1 by x. Now integration of 1 is what? X we have. Okay, with sign is what? We have plus, minus with sign. Okay, this into this into this and then integral of this into this with minus. Now this integral, we can say this is I1. Let's say I1. Now I1 equals to what we have? Integral this what? This into this with plus sign. This equals to e raised to log of x raised to square into, I will write x over here, minus integral of this. Okay, this into this integral. Here minus is there. Okay, minus into this. Here we have integral the x into x, I can get cancel. Okay, but I will write here for time being 2 by x into e raised to log x raised to square into log x into x dx. Okay, now this x and this x gets cancelled. What I have is x into e raised to log of x raised to square minus integral 2 into e raised to log of x raised to square into log of x dx. Okay, now what we have is this. Okay, so I will write this, I will merge with this. Okay, I will merge with this. This is same as, this is my I1. Okay, now substituting this become what? This implies what we have is integral of twice e raised to log of x raised to square into log x dx. Okay, look at here. Okay, this and this gets cancelled. This is twice this. Okay, therefore this and this gets cancelled. Therefore what we have is, we have, this is plus, this is plus. Okay, what we have is, this integration is x into e raised to log x the whole square plus c. Okay, this is the required answer. Welcome back. Let's see this integral of sine 6x plus cos 6x plus 3 sine square x into cos square x. Now let's consider this part. This can be written as sine of square x raised to cube plus cos square x raised to cube plus, let's keep as it is, 3 sine square x plus sine square x into cos square x dx. Now remember, here we have a cube plus b cube. What is a cube plus b cube? A cube plus b cube is same as a plus b into a square minus ab plus b square. Now let's apply this formula over here. This is equals to integral sine of square x plus cos square x into a square means sine square raised square means sine raised to 4x minus sine square x into cos square x means ab plus b square means cos raised to 4x plus this term 3 sine square x into cos square x and dx. Now we have sine square x plus cos square x is equals to 1. Okay. Now this term become 1. Now I can remove this. And we have this sine square minus sine square x cos square x, and here we have 3 sine square x into cos square x. So 1 minus 1 plus 3. Okay. Therefore this can be written as integral this also I can write sine square x raised to square plus. Okay. Now 3 minus 1 is what? 2. 2 sine square x into cos square x plus this what we have is cos square x raised to square. Now integral dx. Now it is solved from a square plus twice ab plus b square. Therefore this integral, this is same as sine square x plus cos square x raised to square dx. Sine square x plus cos square x is what? 1. Therefore 1 square is same as 1. Therefore 1 dx. Integral 1 dx, this is what? X plus c. Okay, this is the required answer. Welcome to the channel. Look at this integral. Okay. So it's very easy. Let's send inside. Okay. Let's send inside and let's see how it works. If I send inside, then integral here x into x raised to e into e raised to x plus e into x raised to e into e raised to x plus x raised to e into e raised to x dx. Okay. Now let's take this common. Okay. So is equals to integral x in this plus this is what? E raised to base are equal, we can add the indices. Therefore e is x raised to e plus 1 into e raised to x plus if I take x raised to e raised to x. Okay, this common, then what I have? E plus 1 dx. Look at this. Okay, this is what? This is what? Differentiation of this. Okay, look at dy. What is dy? Dx of x raised to e plus 1 into e raised to x. What is this? Now apply product rule u into v. Keep x raised to e plus 1, keep as it is. Differentiation of e raised to x is what? E raised to x. Okay. Now keep as it is, e raised to x. Differentiation of e plus 1 is x raised to e plus 1 is what? E plus 1 into x raised to e plus 1 minus 1. Plus 1 minus 1 is what? X raised to e. Okay. Therefore differentiation of this is same as this. Therefore integration and differentiation gets cancelled. So therefore this integration become x raised to e plus 1 into e raised to x plus c. Okay, this is the required answer. Now differentiation of denominator will be what? 1 plus 2023 into x raised to 2022. Now differentiation of denominator is what? This. Now since 1 is there, let's adjust this term. Now this is equals to 1 plus 2023 x raised to 2022 up. Okay, now this is extra. Okay, this is extra, so I am cancelling with 2023 x raised to 2022 and then plus twice x raised to 2022 upon x plus x raised to 2023 dx. Now this equals to this same as this upon this and this upon this. So therefore integral of this upon 1 plus 2023 x raised to 2022 upon x plus x raised to 2023 dx. Now here This x raised to 20, 23, these are, if I take x raised to 20, 23 common, now what I get is 20, 23 minus 2, means I will get 20, 21, x raised to 20, 22. Now I am separating this upon this. Here I will get x plus x raised to 20, 23. Integral dx. Now differentiation of these become what? Differentiation of denominator become a numerator. Okay. Therefore, that this integral is become log of denominator, means x plus x raised to 20, 23. Or you can substitute, you substitute this, and du will be this. Therefore, that is log of u with this. Okay. Minus integral. Now from denominator you can take x common. If I take x common, 1 plus x raised to 20, 22. Here I will get 20, 21, x raised to 20, 22. Now x this x raised to 1. Okay. Now here I can bring this up over here. Then minus 1 means I will get x raised to 20, 21. Okay. Now this x goes. Now let's say differentiation of this denominator. We have dx over here. Differentiation of this denominator is what? Let u equals to 1 plus x raised to 20, 22. du equals to, this is 0, 20, 22, and u raised to 20, 21. X raised to 20, 21. Therefore, du upon 20, 22 is equals to x raised to 20, 21 into dx. Now, this 20, 21 I can send outside, it is constant. So, I am sending 20, 21 outside. Therefore, okay, this is what? This is my du. Okay. Therefore, this is same as 20, 21. Differentiation of this become this. Therefore, but we have 20, 21. Okay. Upon 20, 22, that is log of 1 plus x raised to 20, 22 plus c. Okay. Here this is log of x plus x raised to 20, 23 minus this into log of x 1 plus x raised to 20, 22 plus c. Okay, this integral, okay, this integral can be solved within 10 seconds, but I will solve very slowly so that everyone can understand. Look at here, okay, the angles. Now here we have 20, 30x, here we have 43, okay. So 43 is same as 20 plus 23, okay. Now let's break this. This equals to integral 3 sine of 20x cos of 23x plus 20. Here this is same as sine of 20x plus 23x. Okay. And this is become dx. Now what is sine A plus B? Okay. We have formula sine of A plus B is equals to sine A cos B, since it is plus plus cos A sine B. Okay. Let's apply this formula. Let's keep as it is. Here integral 3 sine of 20x cos of 23x plus 20. I'll use first bracket. Here sine A cos B, sine A cos B, okay. Sine of 20x into, okay, cos of 23x plus cos of 20x sine of 23x. Okay, here this is second bracket and whole dx we have. Now let's multiply inside. Integral 3 sine of 20x cos of 23x plus here, if I send inside, become 20 sine of 20x cos of 23x plus 20 cos of 20x sine of 23x, then dx. Okay. Now here, what is here? Okay, sine 20x and cos 23x. Okay, here, look at here. Okay, now sine 20x and cos 23x, this. Okay, so we can add these two. Okay, so if I add these two, this become integral 2 plus 20 plus 2 is what? 23 sine of 20x cos of 23x, and here we have plus as it is 20 cos of 20x sine of 23x dx. Look at this. Okay, can you find some relations? Can you get some relations between differentiation of this into this? Check what is d by dx of sine of 20x into sine of 23x. See, let's apply unity rule. Okay, this is same as this, I want to say. Okay, now keep as it is, differentiation of sine 3x is what? Cos 3x, 23x into d by dx of 23 is what? 23. Okay, and keep as it is, differentiation of sine 20x is what? Cos 20x into d by dx of 20 is what? 20x is what? 20. Okay, therefore whole this become what? Is equals to differentiation of this. Okay, therefore integration, differentiation and integration gets cancelled, and that is plus c. Okay, therefore this is the answer. Okay, we have not done any substitution, so this is the required answer. Now in this integration we have mix of trigonometric as well as exponential. Okay, now let's do one thing. Let's use some trick over here. So I will adjust numerator and denominator. Let's see, this is half, I need 2. Okay, here 2 sine of x, since I need 2 sine x, so I am cancelling with this 2, is equals to 2 e raised to x plus cos x plus sin x dx. So 2 sin x is same as sin x plus sin x, sin x plus sin x, and let's adjust it. This is equals to half sin x plus sin x upon 2 e raised to x plus cos x plus sin x. Okay, now look at denominator over here. Okay, so we need to get this term. Okay, this we already have sine. Okay, in what? In numerator. Okay, now these two term we need. Okay, so let's adjust with this. So plus twice e raised to x plus cos of x, we need this, so let's cancel this, 2 e raised to x minus cos x into dx. Okay, so let's combine with this. Okay, is equals to half integral 2 e raised to x plus cos x plus sin x. So let's combine with this 2 e raised to x plus cos x plus sin x, means this, let's combine this two, cos x plus sin x minus. Okay, so I'm taking minus common. Okay, so this 2 e raised to x here. Okay, and then plus minus cos x here, minus plus sin x. What I am doing is, this minus 2x minus 2 e raised to x is as it is, so plus minus, this minus cos x is over here, this is over here, as well this sin x is become here. Okay, because minus become plus. Now let's separate this upon this and this upon this. Okay, into dx. When I separate, this becomes same, so therefore it's 1 integral. So half outside we have, as well as integration. Here we have this upon this is, let's say, integral 1 dx minus this, okay, here integral 2 e raised to x plus cos x minus sin x upon 2 e raised to x plus cos x plus sin x dx. Check this, differentiation of denominator is what? 2 e raised to x is 2 raised to x. Differentiation of cos x is what? Minus sin x. And differentiation of sin x is what? Cos x. Therefore, differentiation of this becomes this. Therefore, that is log of, okay, this. So, bracket close over here. This equals to half. So, let's start bracket. Integration of this is become what? X minus this becomes log of denominator, okay, here 2 e raised to x plus cos x plus sin x plus c, or you can send inside. This is what is equals to x by 2 minus 1 by 2 into log of 2 e raised to x plus cos x plus sin x plus c. Okay, you can keep like this or you can keep like this. In this integration, I will be using properties of log. We know that properties of log means what? Log of m upon n is same as log of m minus log of n, as well as log of m into n is same as log of m plus log of n. So let's use this property over here. Therefore, this integral can be written as integral. It is of the form log m by n. Therefore, that is log of x minus log of pi upon log of x here, okay, here I am applying here as well as here, okay. Now m into n is what? Log of pi plus log of e into dx. We know that log of e is equals to what? 1. Therefore, this is same as log of x minus log of pi upon log of, I can separate this upon this as well as this upon this, log of x raised to log pi plus 1, okay, into dx is equals to integral log of x. Let's separate this upon this as well as this upon this upon log of x raised to log of pi into log of x raised to what? X raised to 1, okay. Therefore, you can keep as it is dx, this upon this minus this upon this minus log of pi upon log of x raised to log of pi plus 1 dx. Now, if I cancel these two, what we'll have? We have this, okay. So 1 upon this. Therefore, this can be written as, remember, e raised to minus x is what? 1 by e raised to x, or you can say a raised to minus x is same as a raised to 1 by x, okay. So this I can bring up. Therefore, instead of this, I can write like this, log of x raised to minus log pi, okay. Now let's keep this for time being. Now let's integrate this, okay. Let's integrate this. This can be written as what? I can keep 1s over here. So let's integrate this by di methods, or you can say tabular methods. So di methods Now in integration part I will keep 1, and in differentiation part I will keep as it is, log of x raised to minus log of pi. Now let's differentiate this, something like x raised to n, okay. So here I will get minus log of pi, okay, into log of x raised to minus log of pi minus 1, okay. Something like x raised to n is n into x raised to n minus 1 into dy dx of this is what? 0, okay, we don't have to write anything. Integration of 1 is what? X. Now here we have plus minus sign, and we need to cross multiply this way, and then integration of this into this. Therefore this integral become what? Log x into log of x minus log of pi into x. So I can write x over here, this x, this is plus this into this, so we have this, and then this into this, okay. This into this means what? Minus minus plus, we have integral of log of pi, integral of log of pi, okay, into what? Log of pi into log of x raised to, I can take minus common here, minus common over here, minus, if I take common, log of pi plus 1 into this x, okay. What I am doing is, whole this part is over here, minus into minus plus, plus over here. This, what about this x? This x we need to write over here, into x dx, okay. So what is this part? Look at this part. This is what? This is same as is equals to x into log x raised to minus log pi, okay. Here this I can send down. This is same as plus integral log of pi upon, if I, this is same as log of x raised to log of pi plus 1 into dx. Now this part is this, okay. Therefore this we have minus log of pi upon log of x raised to log of pi plus 1 dx. Therefore this term and this term gets cancelled. So this is the required answer.